Hi everyone, in this video, our group is going to present about vibration of coupled system. My name is Husaini and my friends are Arif, Akmal and Amirul.
Hi, I'm going to explain a brief about project that is vibration of couple system. The main part of the system is spring. There is an object that can be deformed by a force on it and then return to its original shape after the force is being removed. This is stated by Robert Hooke that discovered about the springs and its elasticity, that is Hooke's law. Furthermore, the system also involved Newton's second law of motion that stated that the acceleration of an object produced by a net force is directly proportional to the magnitude of the net force. The vibration itself has two types of system, which are uncoupled system, and the one that we will mainly focus on in the system is coupled system. A coupled system is formed of two differential equations with two dependent variables and n independent variables. The study will also include a normal mode vibration. This mode is a free vibration that depends only on mass and stiffness of the system. The study involves 2 degrees of freedom system. Hence, minimum 2 coordinates are required to present the motion of the system. Therefore, 2 equations of system are needed to solve this system.
This is our mathematical model for our project. Two masses are attached to the wall with a spring, and between these masses are a spring that connects them both. Then the mass will be moved to the right simultaneously. With this information, we can create an equation that calculates the force that acts on each mass with Newton and Hooke's law. The first equation is for the M1, and the second equation is for the M2. And this is the initial value problem, IVP, that we will use to solve the problem. The constant that we will use for easy calculation, M1, M2 is equal to 1, K1, K2 and K3 is also equal to 1.
Okay, after all of that explanation, let's move on to the next part, which is to solve this problem. To solve this problem, we have to find x1s and x2s. So we're gonna use the equation 2.1. We're gonna equate the equation to 0 and then apply Laplace transform, and after some algebraic, we have to substitute the initial condition and the constant value, and then we will get the x1s. Similarly, we're gonna use equation 2.2 to find x2s using the same method for x1s. So now, as you can see, we have 2 equations here, so we're gonna solve this simultaneously. We're gonna put equation 2 into 1 and then we will get x1s, and then we will apply partial fraction to this equation and then we will get the complete x1s. After that, we're gonna insert the x1s into equation 2 to find x2s, and then we just apply partial fraction to x2s and we will get the complete x2s. So now we have x1x and x2s. So we have to apply inverse Laplace to find x1t and x2t. So we just apply inverse Laplace to both sides and then we will get the answer for x1t and x2t. To verify the answers that we have got just now, we use Maple to solve this problem. We just put the equation and the parameters of the model, and then, as you can see, we get the exact same answers as in our manual calculation just now. The xt and yt in the Maple is actually referring to x1t and x2t in the manual solution. And what we have here now is the graph of x1t, the red line, and the graph of x2t, the blue line. For the red line, the first curve is sharp because the velocity for mass 1 is increasing and then decreases, making the second curve is quite curvy, and then its velocity increases again. For the blue line, it's kind of reverse to the red line. The velocity of mass 2 is slightly less than mass 1 during the first curve, but it increases and becomes sharper at the second curve, and then it's slowing down again at the third curve. What we can say is the velocity for both of these lines is always contradict at different curve, and eventually it will become 0 because its energy is lost to its surrounding.
After deeply studying on this phenomena, we are now able to understand the way of vibration of coupled system in spring happen. We have been able to learn on solving differential equation by using Laplace transform. As the study showed, the main factor which affect the system to work is each displacement and velocity. From this project, we have figured out how to apply the concept of ordinary differential equation and Laplace transform. As a recommendation, in order to make things become more interesting, we recommend the system to use block with different mass, spring with different stiffness, and use the system on friction, as some changes in reading and maybe a smooth system could be obtained. Besides, we can also study the behavior of the system when there is no spring involved in the system by replacing it with system of coupled pendulum and even use pendulum with different mass. That's all from us. Thank you.